Okay, welcome to our final class. Okay, there's many people that are here. Okay, that's fine. All right, so as promised, I said I would take a few minutes to talk about the final exam, and we'll even do a little bit of some practice stuff. So I'll explain first of all, just to remind you how it's going to look. It looks an awful lot like the midterm look, is the same time, just one little change. We'll see that in a second. And yes, absolutely everything for the entire course is covered right from the beginning to the end. Okay, so the only thing that's kind of a bit weird. Okay, so yeah, all that stuff is up until the midterm. Of course, then tuples, sets, and dictionaries and complex nested structures. That was up until the lab exam. So the new stuff is the searching, the sorting, exception handling files and CSV files. And of course, the exception handling, you won't be asked to write anything handling exceptions. It will be just like maybe some tracing questions, just like what I demonstrated. Okay, the format is pretty much the same idea as what you saw on the midterm. Instead of 12 questions, it's 15 questions this time, a couple of small ones. So it made more sense in terms of a point mechanism. There will also be 2 programming questions with the online interpreter, and of course that's what happens before. All of the MCQ questions show up first. You'll switch over to the next page. You'll have access to the interpreter, and then you won't be able to go back and deal further with the MCQs. All right, so the MCQs, well, I mean, we've had lots of MCQs for practice, all those lab exercises, the mastery sets, and so on. Those will make really, really good practice. You can always take those, pass it off to an LLM and say, give me more like this to test me, and say that I've got a final exam coming and the questions are going to be harder. It'll probably oblige and give you something harder. All right, the 2 programming questions, there will be 2 programming questions. I really hate to call it something like easy and hard, okay? So it's not really about this time. The issue that I've bumped into before in this course is that I don't really feel good about putting a file question as being the easy one, because if you don't learn files, and you gain nothing. And putting file processing as the second one only worth a couple of marks, it means that people aren't trying it, which is also kind of bad. So I had to sort of balance this out. So it's 15 and 10. I wouldn't describe one as being easy and one as being hard. They are approximately the same, okay? All right, usual stuff, nothing else weird going on. Yeah. Sure. Yes, you will. And here's what you're going to do when you get that pop-up message. Just click on submit or OK to get rid of it. Copy whatever you've done, paste it back into D2L, and just go back, keep going. I'm sorry that it's an annoyance, but it's one of 2 options. You are either annoyed by that, or you will possibly lose a bunch of work that you worked on. I think the first one, being irritated every 20 minutes, is a lesser evil because it's really bad. Okay, it's a D2L timeout issue. I think it has been upgraded now to 1 hour, but I heard some reports of some stuff happening over the weekend. I have to work that out first. Yeah. It should already be at 1 hour. Okay, it should be. Okay, I'm leaving my reminder for 20 minutes for right now. Maybe you'll be lucky and I'll back it off for 40 minutes, but I will have to point that out. Sorry, this is somebody else's decision. Trust me, if it's gone from 30 to 1 hour, it was a lot of pulling to get that done. Okay. All right, so it was the best I could do. Initially, it used to be 3 hours, which was never a problem, and now it kind of is. All right, so in order to help you deal with the exercises here, I thought it would be useful to do 2 things. Because the first question is going to involve nested structure processing, I thought maybe we better do some nested structure processing exercises, and I thought, well, I've already got some questions from the recent lab exam. I'm not sure how you have done, but out of the stuff that I did review, there was actually some very surprising things that people weren't able to do or even get started in terms of syntax, and it was a lot of stuff that I know I've covered here. So in any case, I will just remind you of that. Second question for dealing with the CSV file, I thought what I would do is I would pull up one of the questions out of Lab 11. Not exactly, but we'll make some modifications to it, and we'll work through dealing with the CSV file. Okay, so first piece up is, yeah, let's deal with the existing ones. Okay, so here we go. It also gives a chance to sort of go over this. I mean, there was lots of people who did really well. I ended up with actually, surprisingly, the group of people with A grades was actually like almost the highest group compared to the B's and C's and D's. Yes, there was a group of F's who didn't do so well, and there were a couple of cases of full marks, so it certainly was feasible. All right, but in any case, here we go. So we're given a list of products in a store inventory. You need to generate a list of products that need to be reordered due to a low stock value. Actually, it should be called a low stock count. I mean, that would always be fixed. So each product is represented as a dictionary with the following keys. All right, you can read that, but it's easier just to see. Yeah, it's a list of dictionaries. Okay, and what is it that we need to do? We need to go through and return a list containing the names of the products whose stock is currently less or strictly less than, so not less than or equal, but strictly less than a given threshold. So, for example, down here, I can make that just a bit bigger. Here we go. So in other words, we're looking for the inventory items whose number is less than 5. We're looking for the inventory items whose number is less than 2, which there wasn't any. That actually points out that it's not less than or equal. And of course, it should work in all cases, including empty lists, just in case that's an issue. All right, so let's give it a shot. So, you know, the usual thing, we'll start with a simple case. We'll see how this goes. I guess we can make that a little bit bigger. Okay, so as usual, okay, remember, it's really more of the process than it is the final answer, and I hope that people have learned this. So here we go, inventory and maybe a limit, okay, and I'll simply do a return none just to make sure we got everything in place. All right, so now we can start dealing with this. All right, so our whole idea is to be able to get some of the items like, let's see, mouse and pen. And of course, the reason why mouse and pen are of interest is because their values are 3 and 2, and we're looking for a limit of 5. Okay, usual thing. I think one step smaller would be better. You know how this works. Yeah, you start off by printing something. Hey, look, for X in inventory, just print X. Now, of course, that's not going to be our final thing, but we do this just to find out, hey, what types of problems do we have? And, yeah, for in inventory, okay, 2 ins. Oh, 4X4 in inventory. Yeah, okay. Here, you go away. Okay, there we go. Finally, we got that worked out. But again, it's the same type of issue that I've said before. Yeah, this is why you start these small things. All right, now immediately you look at this and you go, oh, okay, so it's one of these things, and you know, I even warned about this, and yet, like, I found like 5 or 6 of people like this, and that was only in one section that I was responsible for. I saw a lot of people say this. Okay, because they said, "Oh, cool, we can use unpacking." Just remember that when you try to apply this to a list of dictionaries, you actually get the names of the keys, not the values. Okay, so that is not going to work for you. Okay, second thing is, although you could pull out one value and then iterate through each of the items, that's also kind of silly. I mean, I guess you could probably make it work, but I wouldn't do it. No, what I've got up here, this unpacking, that is really, really good for tuples, and for dictionaries it isn't. Okay, so don't try to bring it over for dictionaries. Yeah, all that it is this is something to do with a product. Okay, and here we go, product. Now, of course, we're not interested in all of these. We're only interested in a few of them, and that happens to be where the product is, or sorry, the product's stock, not the stuck, here we go, happens to be less than the limit. Okay, there you go. There are the 2 items. Oh, I'm not interested in all of those. I'm interested just in the product. Okay, maybe it should have been called product name. All right, that would have been better. But there you go. So we're down to this. We've managed to isolate exactly the things that we need instead of printing it. Collect it, yeah. Have some kind of a result instead of printing it. Stick it into a list with an append, and of course return the result at the end. If I was actually implementing a program like this, I wouldn't return it as a list. I would instead return it as a set. Okay, but I left it as a list for this one because it was easier. Okay, and I would do that because I wouldn't care about the order. Okay. In fact, you even saw the question said it doesn't matter about the order, and yes, we did allow in case something got out of order. I don't know why you would process it in reverse, but if you did, yeah, we would have accepted it. But really, a set would have done it as well. Okay, one doc string, and you're done. Okay, so there's the first one. All right, next one. You're given a list of student grade records where students have multiple attempts. You need to determine the highest grade obtained by a student for a given assessment. Okay, each record is represented as a tuple. Okay, so yeah, it's a list of tuples. Now we can use tuple unpacking. And we have a student ID, an assessment name, and a grade. And basically, we just want to find out whether or not something appeared more than, grades have multiple attempts. You need looking for the highest grade. Okay, the multiple attempts is later. All right, so we're looking for the highest grade out of all of these items. Okay, let's give it a shot. And again, same thing. We'll start with something very simple in the first case. Then we'll have to look at a case that ends up with a failure. And yeah, I mean, it's just one extra test case. And you'd have it. Okay, here we go. Highest grade. Okay, so we have a bunch of records. We have a student ID, and we have an assessment. Okay, and for right now, return none just to make sure it works. Okay, good. All right, so we got a whole pile of student records we're going to have to look at. All right, X in records, print X just to see what we've got it. Okay, so yes, we've got some information. Okay, well, the problem right now is everything is a tuple. It's a lot easier if you use tuple unpacking. So instead of being called it this way, what we'll do is we'll call it student ID. I'll use STID so it doesn't conflict with student ID that I'm searching for. The second thing being the ASN for assignment name. Sorry, it's sort of an abbreviation, but we have to deal with it. And of course, grade. And yeah, we'll just switch it over to a print. So student ID, ASN, and grade. Okay, good. So at least now we've got it down to simple types, and that's always what we're looking for. We're trying to break things down into a simple type, integers, strings, doubles, floats, or sorry, no doubles here, floats, booleans, other types, simple types. Collections of things, more difficult to work with. Simple things, yeah, we can just do some checking. Now, what we're interested here is we want to know the highest grade of 6012 in quiz 1. So my question is, do we consider this line in this particular case? Yes, okay, good. Do we consider this line right here? Yes or no? Yes, okay. Do I consider this line right here?
No.
Why not?
It's not the assignment.
Because the assignment name is different. It is the right student, but it is the wrong thing. And do we consider this line right here? No, because it's the ID that's different, even though it's the name of the assessment. So what you're looking for is you're looking for two conditions to be true. Yeah, that's called AND. Okay. All right, so let's just start by trying to filter things. Instead of printing everything, let's ask the question, if the student ID is equal to the student ID that I'm searching for, and let's call it the ASN is equal to the assessment name in question, this is what we're looking for. Few people left out one of the AND conditions, so of course you're dumping everything in. That's not going to work. Second problem is some people, I won't call it a problem, some people use two if statements, an if statement followed by another one. Yeah, I mean, that works. Okay. I prefer one, but you certainly would not have lost any grades for it. So I've got to filter down to the two things. Now, what I'm really interested in, I don't really care about the student and the assignment name. I'm really just asking this question right now, which one of those is the biggest? Because that was the whole idea, was give me the biggest. Now, there's a couple of different ways how you can find the biggest. You can always start off with the maximum value and going through and basically replacing it whenever you get a bigger one. Or, hey, since we have this cool little function called max, why not? Okay, so grade list. Okay, instead of printing it, grade list append, and print grade list. Bang, here we go. Excellent. So now we've got it into a list. And the reason why I put it into a list is because, well, now it's pretty simple just to say, give me the maximum of the grade list. All right, perfect. All good? No, you're missing something. you're missing, so here, we'll leave this print statement in for right now. What's the highest grade that student 6012 got on quiz 5? Yeah, that's an error. Okay, and that's a really big error. Okay, and that's a crash because, well, you can't have an empty argument for max. So always remember, if you're using max or min, just make sure it never becomes empty. Okay, did they say something what we're supposed to do? It says right here, if the student does not have any grades recorded, the function must return none. Okay, so at what point do we know that the student has no grades? It's not something you know right here. Okay, because we haven't even started looking at anything. It's whether or not the student doesn't have, and that will be in the grade list. So if the length of the grade list is equal to 0, then please return none. That will look after. Again, could I say if grade list is equal to empty list? You can say it. I don't recommend it. Okay, I won't take marks off in this course, but you will fail miserably if you take the next course, because it doesn't work in those other languages. All right, so there we go. Once again, quick little doc string, and we're okay. Clean up the print statements. All right. Let's go back to the next one. Okay. Next one, let's see, got a next page. Okay, excellent. Number 4. All right, so you got a dictionary representing budget information for several departments in an organization. Each key in the dictionary is the name of the department. Every department has another dictionary. Ooh, okay, so a nested dictionary, dictionary of dictionaries. And if we come down and take a look at it, yeah, we've got a whole bunch of budgets, and the first key gives you the departments, and the second dictionary just happens to be a key and a value. Okay, so it's basically an item and an amount. Okay, it goes a little bit further. We're supposed to write a function called calculate department budgets that takes budgets and departments, but here's the trick. It's got an exclude category. So in other words, yeah, where you don't just add up everything, because that would actually have been a little too easy. Honestly, because at that point it was really just a sum of the values. So no, it required one extra item, which is in this case when we add up everything for HR, we wanted to exclude the salaries, and for IT we were going to ignore the equipment and security, and it also happened to give us a set, which is good because we had no other sets in any other questions. All right, so let's see what we've got here. So we copy this one in and see if we can work this out. Okay, def. That's pretty lengthy. Okay, I'll let it do this way. All right, so here we go. This is a budget. Okay, this is a department name. Okay, I'll write them up pretty big. And I'll call this the excludes. Okay, and we'll return none just to make sure we got it. All right, so we have everything set up. Now, the immediate thing, you look at this and you go, okay, so I've got a dictionary. So how do you deal with a dictionary? We go through iteration and you iterate over all the keys. No, you don't. What we're trying to do is we need to isolate either HR or IT or something else, because remember, this could go on with a whole bunch of other things, given the key. If you know the key, it means you don't have to loop for anything. You can just go and get the full department budget in one shot. So we can do something like this. Dept budget is equal to, you go to the budget dictionary and you simply ask for the department name. Let me print the department budget to show you what we've got. There we go. See, that's the HR department's budget. Okay. If it was IT, it's no problem. It does exactly the same thing. You don't need to iterate through because you know the key. If you're trying to find something in the value side, well, then you have to use iteration. But if you know the key, it's just simple lookup. That's the reason why we have these things called dictionaries, is to solve problems like that. Okay, so we've managed to extract this. Now, with our department budget, well, it's going to be just a matter of going through and adding things up. Let's start as usual. Let's try to make the thing appear. Oh, and yes, there are cases in here that are really going to mess up. We'll deal with those afterwards. Remember, I've made this comment before. You don't start with the hard cases or the off cases. You start with the simple things. The general case, that's the more important one, not the edge cases. So why don't I just go through all the department budget, print X. Now, if I do this, what will end up happening, I'm typing this again. My fingers are really messed up here today. And that's an int. Okay, how about now? Excellent. Okay, depart budget. Okay, a department budget. Oh, it's called a dept budget. Okay, dept budget. Okay, copy and paste, I guess, would do it. Let's do this. Okay, just put some before and after stuff. This is just for helping. All right, so, okay, those are the names of the items. Okay, but I not only need the item names, I also need the values. All right, so, but of course we already know that if you stick in the word values, that only gives me the values, but it doesn't give me the names. Now, if I just needed to add up everything, I wouldn't need the items. Unfortunately, I need both things. So the most appropriate thing, yeah, use a dot items. All right, but that of course is a tuple. And the easiest way to deal with tuples is use tuple unpacking. So the first thing is, let's call it the item, and the other thing is called an amount. Okay, and let's print the item and the amount. All right, good. So I've managed to separate the items and the amounts. They're now down to primitive types, which means that we can probably start doing something with it. All right, so what can we do with it? Well, we're supposed to add up everything. Okay, well, I mean, I guess one way that we could add up everything is we do have the cool little built-in function called sum, except that it only works if I have a list. Okay, and by the way, if you want to set total is equal to 0 and iterate through and do the stuff that we learned in 1101 and the beginning of 1201, that would be completely fine. There's no issue. So what I'm going to do is I'm going to call this the amount list. I'm going to start off here, and I'm going to put everything in for right now. Then we'll fix it. So instead of printing, I'm going to say the amount list, and I'm going to say append, and I'm going to append the amount. And I am going to just print the amount list at the end. Okay, obviously I could do a sum, but the issue is right now is this would sum everything, including the things that show up in the excludes. Okay, yeah, I don't want those. Okay, so how do we deal with this? Okay, let me undo this for a second. I'll go back to what I had. Let's put in the filter. Okay, so here we go. If the item is not in excludes, because that's how you find out whether or not something is there, those are the items we're interested in. Okay, and you could say if item in excludes, do nothing else printed. Okay, that's fine. That's kind of a backwards logic. But the item non-excludes is probably a bit better. So instead of printing it, now let's go forward what I was doing before. So we'll call this the amount list collected, and instead of printing it, the amount list dot append, and we will put in not the item but the amount. Okay, we're almost there. And finally, we will print the amount list. Okay, and we do a very quick little check. Is that giving us the right information? And the answer is yes, it is. You could even do a quick little check. 8,000 plus 3,000 plus 2,000. That is 13,000, and that is the number we're expecting to get. Of course, we don't want to print or return the list. We want to return sum of the amount list. Okay, and there you go. There's the 13,000. Now, finished? No. There's a couple of really important cases that we have to look at. Okay, so the first one up is, how about if I exclude the salaries? Should this work? Should it fail? What should happen? What do you think? I know the question didn't ask this, okay, but let's just think about it. If it excludes the salary, basically that would add up everything. Yeah, and that'll just include everything, including the salaries. I suppose something we should check is, what about if the salary or if the set was empty? Yeah, that would include everything, because nothing is in there. That's reasonable. Here's the one that I know is definitely going to be a problem. What about for the HT department? Okay, so what's going to happen if I replace HR with HT? It's a key error. Tell me which line. 2, very good. That's exactly where it's going to happen. Okay, from line number 29 we called the function, and on line number 2 we couldn't find it. How do you prevent yourself from having a key error? Have an if statement. If department name not in department budget, you're going to return something else. I have no idea what to return. Otherwise, you're going to keep going. Okay, so what did it say over here? Your function must work. Here, if no categories meet the conditions, actually, that should have been a question you should have asked. It should be if no department met, then what we would do is we would obviously return a 0 in this case. So yes, that could have been a question. I think a couple of people asked, but probably not enough. So a 0 in this case. Okay, let's find out. Department budget. Oh, wrong one. It's budget at this point. Department budget is what we get afterwards. Okay. All right, I don't think anything else would have ended up failing. That would be the usual one, is when you look up something for a key and the key isn't there. All right, so here we go. Next one. So this is given a list of tuples representing assignment attempts. Oh, exactly the same. Hey, good. If I get a data set, keep on using it, ask different questions about it. So each tuple has the following format: student ID, assessment name, grade. Okay, that's fine. And we're looking for a function called has multiple attempts that determines basically if any student has taken the same assessment more than once. Okay. All right, so right here, did any student take the same assessment more than once? Yes. 6012 took quiz 1 twice. Okay. Now, this could be a much, much more difficult question. You could be asking which grade should we keep? Well, now you're looking for a max. It's a considerably more difficult problem. I could ask you to tell me which students had taken things more than once. That was also a different problem. But in the end, I figured, okay, well, no, just was there a case like this? Okay, well, let's give something a try to see how this goes, and we can manipulate things to put in extra duplicates or none at all. Okay, so here we go, multiple attempts. Okay, fine, has multiple attempts. Okay, records, that's fine. You know what, just for fun, we'll start this way. So for R in records, print R, just to see what we've got. All right, now, of course, what we have is a list of tuples. Well, we already know what we should be doing with a list of tuples when we're iterating over them, because we're going to have to look at every one of them. There's no simple thing. You can't count it twice, because if you're counting things, everything needs to match, and that's not what we've got. STID, ASN for the assignment name, and the grade. All right, I'm going to print this once again. STID and ASN. Okay, there you go. That's the information that I need. Okay, that's the information that I need. Now, the question becomes is, what do we do about this? Okay, remember a good friend, the set? What's sort of special about sets? There's no duplicates. You see, if I took each one of these strings and I put it into a set, how many items would be in the set afterwards? 3, yeah, good. And how many, if I took these items and put it into a list, how many items would be there? 4. So if there are 4 items in a list and 3 items in a set, that must mean there must have been at least 1 duplicate. Okay, yeah, that's kind of like the interesting little twist on this one. All right, so the question is how on earth do I put this into a list? Because I'm going to start by putting them into a list, and I'll talk about a couple of different ways. So let's give this a shot. What do we want to call this? This isn't really temp. Maybe this is the, and by the way, we don't care about the grades. We just want to know whether or not it appears twice. That's why I didn't bother printing the grades, because I don't care about them. Let's call it the attempt list. Okay, you know what I'm going to do. I'm going to use an append, attempt list. Okay, so let's start appending things. Okay, here we go. Attempt list dot append stid. This would give me a list of all the students. That's not useful because, I mean, one student could take 2 different assessments, so that's no good. If I ask for the ASN, that's also not good because, I mean, I can see quiz 1, quiz 1, quiz 1, but I don't know who it is. Okay, I don't know if it's one student or the other. I really kind of need both. And you have a couple of options. Look, one option is you could do this, where you could pass in, say, a tuple. Okay, if you don't like tuples, yeah, I've got a slightly different way. this wasn't exactly what I was thinking, but I saw it afterwards, like, hey, you know what, this could also work. You see, if I take STID and I add to it a space and I add to it the ASN, that's going to fail because STID is an int and these other things are strings. I'm talking about old print style stuff that you would have learned from 1101. But what if I did a typecast, again, just like we did from 1101? What I'm doing is I'm building up strings with the student ID, a space, and the assessment name. Okay, and it'll always be this way, so as long as the assessment names match. So if you don't like tuples, this would also kind of work. You don't even need the space. You could even put commas between them. You could put anything at all between them, and we'd have everything. Okay, good. So we have an attempt list. Okay, well, let's have an attempt set. How do you get a set out of a list? You type set, and you pass in a list. So here we go, an attempt set. Okay, so if you ignore all of the input, just take a look at the output. How many items are in the list? 4. How many items are in the set? 3. So therefore, there must have been at least one thing that was duplicated. But what if there's 5 things, or what if there's 2 things duplicated? No problem, then you'd have even a smaller one. So that's the question is the number of elements in the set less than the number of elements in the list? So, ready for this? If the length, return whether or not the length of this attempt set is less than the length of the attempt list. Oh, we have to spell attempt set correctly. There you go. So, yes. Okay. A couple of people went through and they tried counting things. It worked. It certainly worked, and they got their grades for it. What they did is they built up a list that kind of looks like this. I think I even saw one with a tuple. And what they did was they looked at the very first element and they said, okay, now take the first element and count how many are there, because we have a count function. And if that count is ever bigger than 1, then return true. And yeah, that also works. And I also saw some people using nested loops of doing exactly the same thing. It works, but I think this might be kind of one of the shortest ways out of it. Okay, and it's just, again, just thinking about the properties of lists and sets. So build up a list with everything, throw it into a set is kind of the quickest way. But iteration, looking for things and pattern, yeah, it would also work. Okay, so that's that one. Okay, and one more in here. Okay, so we're given a list of tuples representing student program registrations. Okay, on to the students again. You need to produce a dictionary that contains a list of students per program. Okay, well, that's very, very familiar to stuff that we've done. However, a student may appear multiple times in the list if they change programs. Yeah. When this happens, the last occurrence in the list is the student's current program, and there was an example included. All right, so you can see, for example, that Alice was in IT and eventually switched over to engineering. So that needs to be worked out before we start to worry about these types of things. But otherwise, I mean, this was an exercise that was done in the labs in a couple of questions. Take all this data and basically reverse it and build up a dictionary full of things. But the very first thing is to figure out, okay, which program are people in? That's really the important thing. Okay, so let's see how this goes. Not from there. Not from there. There we go, that's the right one. Okay, group by program records. Return none. Okay, good, we're up and going. Now it's a matter of figuring out what we've got. Okay, so here's what I'm thinking is, why don't we just iterate through and try to figure out what the latest program happens to be. You see, what I want is when I find Alice in IT, I'd like to record that fact, but then when I find Alice again in engineering, I want to replace that. Well, taking something that you find and replacing it later, that's a really, really good use of a dictionary. So let's call it current registration. And what this is going to do is it's going to tell me which programs students are in. So let me go through are in records for a second. I'll fix that. Print R, what have I got? Ooh, I've got a tuple. Okay, we already know the answer to this. That's the student, that is the program, and we will print the student and the program. Okay, we've got the program. Okay, there we go. So we've got those all separated down into basic components. And now what I'm going to do is I'm going to ask the question, if the student not in current registration, then I'm going to say that the current registration, in fact, I don't even need this. Yeah, just forget that. I hardly even need to do anything here. I'm going to say that the current registration at the student is equal to the program, and I'm going to print the current registration. I don't even need if statements for this, because I'll just overwrite whatever I found before. Okay, so you see what happened was, yes, we did find Alice in IT, but eventually it was replaced with Alice in engineering. Okay, there we go. There's our first one. Okay, next piece. Okay, now we need to go through and we need to look for all of the programs and basically build up a list of students. I'm going to go through the current registration. So for X in current registration, print X. And I'm not going to print this stuff right now, just print X. All right, oh, those are just student names. I'm going to need the programs that they're in as well. Items. And yeah, I think you've probably realized, like, whenever you're iterating over dictionaries, yeah, we definitely need items. Remember, if I was only looking for a student, that's easy. It's just a key at this point. I could still build up the same dictionary and then just index into the dictionary. I wouldn't need a second thing. All right, so this is student and this is program in. All right, so I'm going to print the student and the program just to make sure I've got everything. Okay, so that happens to be the thing, and what I need to do is I need to build up a dictionary with IT as a key and then Bob and Alice as elements living inside a list. All right, well, as I said before, this we've done in the labs, okay? And I've definitely done this in the lecture. So here we go. We will ask the question, if the program not in result, okay, this one I think I need, I will say that the result at the given program is an empty list, and I can just say that the result at the program, and I could append the student. And I think we should be fine just to return the result. Okay, ooh, now we need to look out. Okay, what have we got? Okay, line number 9, that's about the only thing. Oh, is equal to an empty list. Result at program. Result at, if program not in result, result at program. Oh, okay, so let's read the message. Should I be putting this into a list? No, remember the final output, sorry. It was a dictionary, yeah. Sometimes it happens. Okay, yeah, it's a surprise. Sometimes you look and you go, what? Just read the message. Usually the messages are pretty clear. And if not, if you ever get into a situation where you don't know what it is, well, remember what I've said before. Stop, look at what line, print something just before you're accessing it, and print as type. Okay, so that will usually give you the answer. All right, so there we go. So the second part was perfectly fine. The first part was kind of a little bit of a different idea, but again, it was the very last question. Okay, and people who did this one generally did it this way. I don't remember seeing other weird implementations. Okay, good. So there we go. There's the first thing. And as I say, the first question is about processing nested data collections. So yeah, it's basically a second shot at a lab exam type question, but not the really difficult ones, the simpler ones. And I think if you take a look at what I've done, I think you'll realize that the first 3 problems were really not that difficult. It was nothing really out of whack compared to what we had done in the lab. So yes, the last 2, as I said, these were made for the stronger students, and I certainly had a lot of students get it. Had a few students get it. No, I'm going to leave that. So let's just leave this. Okay, over here. All right, so quick little deal. How are we doing for time? Okay, 20 minutes. I think we'll be done with this. because the second problem is about dealing with CSV files, I thought I would do a quick little review about what we did. It hasn't been that long, but it's okay, I can do it again. So here's the situation. I'm not going to do problems 1, 2, 3 exactly in this order. I'll probably kind of make them up, but I think this is a good spot right here to start as problem number 3. And there's a couple of surprises in here, and we'll talk about how to fix it. We'll also talk about what I would put and what I should put, okay, because that's also reasonable. All right, so here we go. It says write a function called load employees given a file name that reads the data from a given file name. Okay, and the data that we're talking about is this information right here. So this is the stuff we will toss into the file manager. Very, very strange. I was invigilating a, here, delete that one. I was invigilating an 1101 exam over the weekend, and I saw students using this. We don't learn files there. What they were using it for, they were keeping their different programs in it. Don't do that. My warning, it isn't that you can't do it, but the problem is if you refresh the screen, all of this stuff goes. Okay, so just remember the file editor stuff, it's temporary. The code will recover, but the files won't. Okay, there were some issues with that. All right, so this, of course, is a CSV file. It contains a bunch of data about employees, and sorry, we just had to back up. We will call this employees.txt, and we will save it. And of course, that's a CSV file that we are going to read into a dictionary. Okay, now where do we go? All right. Write a function called load employees with a file name. Okay, fine. So we need a function, def load employees. File name. So that's just a regular everyday file name. Okay, so I'm just going to return none for right now, and we're going to try calling this function, and we'll get back a result. I'll call it RES, or maybe we'll call it imps for employees. We'll say load employees. We'll pass in the name of a file. I called it employees.txt. Okay, and print the employees, the imps. There we go. Okay, we've got our problem up and going. Of course, now we need to actually do something. All right, so let's see if we can read in a file. Okay, first step in reading and dealing with a file, open the file. All right, so let's call it the emp file. Okay, you need to open it. What's the name of the file? Well, it's called file name. It's coming in from outside. I know we've been hard coding it all along, but this is probably a little bit more flexible. That way I could have different files, and I could have like employees 2026, employees 2027, and the same function would work. All right, and of course the second thing is the mode, and yeah, we want to open it for reading. All right, so there we go. At this point, you could read the entire contents, but the problem is everything shows up as a string. Now, this file, of course, has a certain format. It's a CSV format, and we know that there's a package that's around to help us. The package is called CSV. Okay, so yeah, let's bring it in. It's a CSV. Now, unfortunately, CSV package, or the CSV package, has this one kind of annoying thing, which is if you want to be able to read CSV files, you have to understand the concept that there's another thing that you have to create called a reader. I'm sorry, not my decision, it's the package. Okay, and the way how the reader works is, yeah, we'd have like this thing called an emp reader, whose job in life is to read the file. The way how it works is you create a dictionary reader. And it takes as a parameter a file. Not a file name, but a file that is already open. Okay, at this point here, for x in emp reader, I'm going to print x so I can see what we've got. Okay, so what's happening is it is generating a whole bunch of dictionaries, which is really cool. The only thing left for me to do is to collect the information, stick it into a list, and return it. It's not that difficult. All right, but we've got two things we've got to deal with. All right, before I go any further, I'm going to ask about salary. Do you see any potential issues with my printing right now in the right-hand side in terms of salaries? Okay, what's the problem? It's a string. And guess what? Eventually, we know what's going to happen is we probably want to do something with the salaries, like maybe add them up, maybe find out how many salaries are coming from, or how much the total for engineering is versus something else. Or maybe we put it in and say, okay, here's one of these reverse dictionaries we did already. So that being as a string, that's not going to work so well. The other value happens to be years worked, exactly for the same thing. So I couldn't ask a question like, what's the average number of years worked by people in engineering? Not while they're a string. So yes, we have to convert those things. I showed you how to do that. There's another issue, and it's not so clear. It wasn't meant as a trick question, and I will tell you what I would end up doing, but there is something that's a little bit different. Okay, so take a look at this. Okay, maybe what I'll do is, let me see if I can get both open at the same time. Okay, so there's the example down below, and here's the example up top. So you can see in the example below, the salary and the years are definitely converted into integers. Very good. What else is different? Yeah, it's all in lowercase and it's spelt a little different. I mean, name, it used to be name with a big N. Now it's just name. It used to be department. It used to be salary, and it's actually a little bit worse because now it's called years, and in the CSV file it was called years worked. Okay, so there's a bit of a discrepancy between the two. Okay, now, would I ever do something like this on like a major assessment? No, I would not put in any type of discrepancy. So we have two things that we can do. We could either change the problem. I mean, okay, you can't do this on an assessment. I wouldn't do that. Another option is, well, just, here, go away. The other option is, well, change them in here. Okay, yeah, and this is honestly what I would do if I was sticking something like this on a major assessment. I would name these things as all lowercase and call the last one years. Okay, that's what I would do. However, since we're not in an assessment, let's go through the process about what you would do, because it's not impossible. So you might as well know all of the options. So one is change the problem. Another is change the data. And a final one is probably just to do the right thing. Take the data that you're dealt and turn it into what you need. Okay, because if this function says it must be in this format, guess what? It must be in this format because other parts of the system later are expecting years, not years worked. That's why it's really important to be consistent. And as I say, when you have like a real set of data, well, okay, so yeah, sometimes I do stuff like this. Sometimes I'm pulling data out of PeopleSoft and I'm merging it together with data from D2L. Guess what? There's a whole lot of discrepancies. Things like first name, last name, yeah, these have completely different fields. What do I have to do? I do whatever I have to. If it's data is going into D2L, I have to get it into the form that D2L deals with, even if PeopleSoft is giving it to be in the wrong format. So yeah, it's something you have to actually know how to deal with. Okay, but hey, on a major assessment, I wouldn't make you do that because we haven't seen enough of it. All right, so here's what I'm going to do is let's put it into the right format, all lowercase, of the correct types. Okay, well, we're going to have a list of employees. I guess that's going to be my result. Yeah, we're going to append some stuff. Result.append, but what on earth are we going to append? Well, I don't want to append just a full thing called X. Oh, let's give it a name, emp. Okay, that's probably a better name than X. Here you go. By appending emp, and then of course returning it, there we go, result, that of course is not giving me the right stuff. Instead of appending emp entirely, just make a new dictionary with exactly the things that you need. Okay, well, what is it that we need? We need a name. Okay, where are we going to get the name? Well, it's called emp name, spelled this way. All right, next up, we have a department. That's an emp department, uppercase. We have department, we have salary, emp salary. Well, it is, but since we're here, why not convert it into the right type? All right, and we have years is the final one. And again, we'll just also do the conversion. We'll turn it into emp. Okay, and here we go. It's called years worked in that dictionary. Okay, all right, Rex, comma, oops, sorry, I forgot one right here. Okay, that wasn't too bad. It actually said line 11. Yeah, that's nice. Sometimes it says the next line. All right, so there we go. Do we have it in the right format? Yeah, now we've got it in the right format. All right, excellent. So let's keep going. Now, here's where I deviate a little bit from the problem because this problem doesn't exist, but I've managed to read the data. It's now in the correct format that I can now work with. I thought would be really cool would be to write a function called this. I mean, everybody likes to have salary increases. Let's increase the salaries. Okay, so here's some list processing. I'm just going to do a return. We'll talk about what we're going to return in a second. So I'm going to read the data and I'm going to increase the salary. Now here's what I'm thinking is I'm thinking a function that, here we go, emps, and then print emps. All right, so what I'm thinking is I'm not going to make a new dictionary or new list of dictionaries. I'm actually just going to modify everything in place. But it depends. I mean, there's many ways of doing it. I don't really have a problem, so I'm getting to make it up. All right, so what are we gonna, or how do we increase the salary? Okay, we're gonna do something really simple. We're gonna add a 10% bonus to everybody. Okay, so how do you add a 10% bonus to everybody? Okay, iterate over everything. Emp in employee data print emp. Okay, there you go. There's all of the employees. Here, let's put a separator here. That's a print. There we go, print. All right, so I'm just interested in the stuff before the horizontal separator. All right, so there we go. That's everything. That, of course, is before things. Well, if you want to increase the salary by 10%, well, just go into emp at the salary and take the emp at the salary times 1.1. That'll do it. That'll give you a 10% increase. All right, so what do you think? Okay? Okay, but there's one kind of weird thing. Take a look at Bob's salary. Bob's salary is now 55,000.0000000001. It's pretty precise, isn't it? All right, what's happening? Well, unfortunately, here's the reality. You know, when you first start with the INFS 1101, I bet you were thinking that everything that you ever record inside a computer was probably a float. Because it kind of makes sense because the decimal numbers are everywhere. Like even money should obviously be decimals. But sometimes, unfortunately, the issue with floating point numbers is they have a bunch of really weird inaccuracies. You can actually take an entire course about inaccuracies in floating point numbers. It's numerical stuff. Yeah, it turns out that floating point numbers are not that great for a lot of things. So an easy fix out of this, by the way, is just make sure it gets stored back as an integer. There we go. That's probably it. Basically, you truncate all of those fraction pennies. Most banking systems, by the way, don't use floats. Use ints. And well, yeah, but if I have like 1.5 riels in my bank account, yeah, that's fine. What they do is they store it as 150. They don't store it as 1.5. They store it as 150 because there's nothing smaller than the fraction. All right, so let's continue on with this. So now I've given everybody an increase. That's very generous of me. Now, what are we going to do with this increase? Well, why don't we put it back out to the file so that somebody else can look at it. Okay, so let's have one more function. Again, this is also not in here. So now what we'll do is we'll call it save employees. That sounds kind of funny. Save the employees. Oh, I don't even need a return here, do I? Return none, not doing anything, that's fine. All right, so the only thing left is now to save the employees. Now, we need to figure out what on earth this means to save the employees. Okay, and of course what I'm talking about is taking all of the data which is currently in memory and pushing it back out to the file. Okay, well for that, I'll need an emp file. And I'm gonna have to open the file. I will pass in the file name, and this time, instead of opening it for reading, I'm going to open it for writing, which of course is a W. Remember that if you open up a file for writing, everything that was there will now be gotten rid of. Okay, good. All right, next thing I need to do, I need to go through and I need to deal with everything. Let me start by printing it to the screen first. If I can print it to the screen, then I can send it to the file. That's always my recommendation. If you're trying to write stuff to a file, make sure you can print it first. If you can't print it, you can't write it. All right, so I'm not going to just do a print. So what would we do? We'd probably have something like this. For emp in employee data, print emp. Now, while I'm here, let me get rid of other things. I'm going to say save employees, employee updated.txt, emps. Why am I sending it to a different file? Well, because remember what happens when I run this, it will overwrite everything. If I put it back into employees.txt and I make a mistake, what happened to my employee data? It's all gone, and I got to copy and paste it again. This is a life hack when dealing with files. You kind of get things to work first, and then you start trashing your files. You don't start by saying, I have no idea what I'm doing, but let's just try it. That's not a good way to work. All right, so what we'll be able to do is we'll just go to another place. I'm not even writing it. I'm just printing it. Okay, right format? No, this is not what's supposed to show up. What we're supposed to see is we're supposed to see things like Alice, engineering, Alice, engineering, 77,000, 5. That's what we're looking for in the file. Let's make sure we can see this. Okay, and again, if you can't print it, you can't do anything else. So the way how I would do this is I'd probably use an F string to do it. I would pass out the emp name with a comma followed by the emp department, followed by a comma, followed by the emp salary, followed by a comma, followed by the emp years. Okay, and what have I got? I'm missing, what am I missing here? Okay, I'm missing a whole bunch of them. I forgot to put this and this. Okay, this one, see, it's so long that we go not dealing with formatted output, we forget how to deal with it. Okay, here we go, and here. All right. All right, does that look like the required output? Is this what should go into the file? The header, good. The header's missing. Where's the header going to come from? Well, if you want a header to appear, you have to do it yourself. It should be name, it should be department, it should be salary, and it should be years worked. There we go. Is that what we want to see going into the file? Yeah, good. Okay, excellent. Once you can see it on the screen, well, now we can actually try putting it out there. All right, so instead of a print statement, it's pretty easy. Not append. Write. Emp file write. There we go. Instead of print, emp file write. If I do this, we got a mistake. I'm going to do it anyway. Okay, I ran. Okay, that was incredibly boring. How come I didn't see anything? Because there's not a single print statement in here. Okay? Sometimes I have students asking in the test, how come I can't see anything? It's like, well, what are you expecting to see? All right, let's go find out if I actually got a file and if it contains what I'm looking for. All right, I do have a file, and is that what I want? Oh, hang on. All the data is there, but it's all in a single line because something very, very important about the write operation, there are no new line characters unless you actually want one. Okay, so if you want one, you have to put it yourself. There's nothing automatic. Here you go. So there's the two. I'm going to run it. Sorry, I don't know if I ran it or not. We'll run it. We'll take a look at the file manager, pop it open. There you go. This now looks like the correct format. So instead of putting it here, what I could do is I could put it on top of employees instead. And then I'm going to just introduce one quick little thing to put it as a heads up for your database course. Don't worry, it won't be a question, but okay. let's suppose I just do this. It's just for you to think about. Okay, we're completely finished, nothing to do with this course. All right, what could go wrong? Well, a whole lot of stuff could go wrong, but let's suppose. Remember, when you trace through this program, the very first line that gets executed, sorry, I'll move that off the screen so you can see the number. Okay, which line? You guys know this by now. What's the first line that happens? Okay, I suppose the import does happen. Afterwards? 28, very good, because that's the first thing that's not inside a function. All right, so I load the employees. Okay, and it jumps up and does a bunch of stuff. After it finishes the function, it comes in and does line 29. Very good. After 29, it goes to line 30. Line 30 jumps up to, or sorry, from line 30 goes up to jump employees right here. I end up on line 21. I then end up on line 22. What does line 22 do? It erases the employee data. All right, now let's suppose I go down to this step right here, and then suddenly the power is lost. What happened to all my employee data?
It's gone.
It's gone, yeah, good. Okay, keep this in mind when you take the database course, because that's one of the things that databases will help protect against this type of thing. Okay, or what happens if you're halfway through writing it and something happens? Yeah, you lose half your employees or something. As I say, it's not part of this course. It's just because we're talking about it. Yeah, this is a reality of life. And you might say, how do you prevent stuff like this? Well, there's lots of techniques. It's just not things we do in this course. And if your comment is, yeah, we'll just make sure you get a battery backup, yeah, that obviously helps. But yeah, there's actually techniques for dealing with this. All right, so there you go. There's sort of a quick review about how to deal with CSV files, both reading it in, putting it into a structure, processing it, and then of course writing it back out. And that's essentially what that module 11 was about. It was just we staggered up into a bunch of smaller steps where everything is kind of done. It just isn't done as one of these things because, well, suddenly it becomes sort of a bigger program. All right, so finally we have ourselves at least multiple things, multiple functions where we're taking something, using as the input for the next, using as the input for the next. So that's kind of cool. All right, that's it. So somewhere in here, I've got to stop for the recording.